Oh, good evening again, gentlemen and ungentlemen. I hope I have the audio levels corrected this time. I have gotten the terminal board working without the CPU board installed. Let us hook up the speaker, and you can see that you can hear perhaps that we're getting a beep. Very good. Now let's unhook all of it, because I think I see something wrong here that we need to fix. Alright, so we need to get this video analog board out of here so we can take a look at it and test some stuff. This of course has all the flyback stuff attached to it, and we have to be a little careful with that. So the first thing we want to do is discharge the anode. I know a lot of the time I bitch and moan about people that get all crazy about working on like wall current stuff and acting like it's super dangerous and will kill you if you look at it cross-eyed. But there are actually, I hate to be that guy, but there are actually dangerous voltages underneath these anode caps. So what we're going to do is discharge the anode. Maybe you've seen this before. If not, well, here we go. So I've just got a clip lead here. I've got it grounded. Note that these brackets that hold these cards aren't grounded. We've got it hooked onto this heatsink backing plate thing on the power supply. That's ought to be grounded. And then you can see the anode cap over here. Actually, maybe you can't, considering the angle that the camera's at. One moment. Let me prop it up here some. Now you can see it. The anode cap right there. And so underneath of that anode cap, built into the CRT, there's a little metal lined hole. And the anode cap has a metal clip that clips into that hole. And there are kilovolt levels of voltage on that anode when the CRT is running. There's supposed to be discharge resistors in this stuff that discharge those anode voltages when you shut the machine down, but you can never be 100% sure that everything's working right. So we want to discharge this anode. So what we're going to do is we're going to take our long skinny screwdriver and we're going to just stick it down underneath of that cap, being very careful not to touch any other metal stuff in the process. And we're only using one hand here. That's a safety precaution. So we just kind of get down underneath of that anode cap, and we're just going to punch around very gently until we touch that clip with our grounded screwdriver, and that will make sure that there are no hazardous voltages remaining. It'll discharge any hazardous voltages that remain on that anode. So with that being done, hopefully it's safe to work on. Again, sorry for being that guy, but I don't want to get sued if you do something stupid and blow yourself up. Now, I am not exactly sure how this comes out of here. It looks like a project and a half. This whole bracket here is going to have to come off. There's another screw up here that I can't get my nut driver on, probably. I guess they expect you to remove the CRT or use a ratchet wrench for this. I don't know. I'll be right back. Let me do this off camera. Alright, so I did have to unplug the anode cap. There's no way to get this flyback off of here without screwing with a bunch of stuff, but you've got to be a little careful when you unhook these. They've got this metal clip under them, and the clip is easy to break. You've got to kind of go in there and push each side a little bit and kind of work it out kind of slowly until it pops out. Because if you try to pry it out of there, you'll break it. Ask me how I know. And now we have to get the thing out of here, being very, very careful not to fuck up the CRT. So I'm going to try to unplug this connector down here that you probably can't see and take this driver board loose so that it's not interfering with the CRT neck. The older version of this video board, like is in those two terminals, doesn't have this extra driver board for some reason. Okay, let's get this back here out of the way. And now we'll try this again. Here's a connector that needs to come out. And I think that's all of them, the other connectors for the flyback. Let's very carefully try to ease that bastard out of there without fucking anything up. This dag wire is going to have to come. That's just on a spade terminal there. Okay, and we've got, that's keyed. This is keyed, I think. That's not keyed, but it's the only 4-pin connector on there. Got another one here. No, here's another 4-pin connector. Well, I've got it on film, so I can go back and watch it in reverse to find the wire colors and stuff. Here is our video analog board with the flyback and all of this stuff. So let's take a look here and see if we can identify anything untoward going on here. This resistor here is pretty toasty. Flip it out of there and see if we can tell. That is not good. But the question I have is what caused that resistor to give up the ghost? And what is going on with this shit down here? Is this transformer kaput? So that is 0.2 of an ohm on that side and 8.7 ohms on that side. I think that maybe I should remove that transformer and look underneath of it, because there's a lot of ash down there. Although it's probably just from that resistor blowing up, but I don't know. And the question is, why did the resistor blow up? Like, if it were going to drift out of spec, you would think that it would drift higher in value and therefore run cooler. I don't know. But if that transformer, 254, yeah, if that transformer was shorted on that side, that might do it. I don't know. I think I've got something figured out here. That I thought at first that it was R254 down here. That's all I can zoom in, sorry. I thought at first that it was R254 down here, but it isn't. It's actually R256 up here. It's a 2-watt, 1.2 ohm resistor. I probably don't have something like that. And it supplies 53 volts to the high side of the primary of the flyback transformer right here, right? So if that was open, that explains why we were getting no horizontal deflection or filament voltage. This is the filament voltage winding down here. This secondary winding on the flyback transformer goes over here and all around and powers the CRT filament down here. So, yeah, that's, shit, where'd I go with it? That's really something there. If this transistor had gone into a dead short, I don't think I think with the impedance of this, of the primary of the flyback here, I don't think it would have burned that resistor. It was a real pain in the ass to get those boards out of there, so I think I'm going to... I make fun of people that just shotgun recap stuff all the time because I'm an asshole like that, but I think I'm going to do that because I don't want to take the thing back out again when I discover that there's another capacitor bad. So I'm going to pull these and test them and see what they look like. I pulled this transformer just to check it, and I think that all of this shit right there where that resistor had blown up is all cosmetic and doesn't actually affect the function of the transformer. You can see where the lead comes off of it there, goes down in there to start the one side of the winding, and the lead on the other side is also attached, and this side over here looks good too, so I'm going to solder that back in. However, this is one of the pads that burned resistor was coming up through, and it has lifted. So when I solder in the replacement, I'm going to have to do some rework here, which is unfortunate. I doubt I have a 2 watt 1.2 ohm resistor, but I guess I better go check. Indeed, I do not have any 1.2 ohm 2 watt resistors. So that gives us some options, alright? Either I can put in a 1.5 watt 2 ohm resistor, I can put in two 2.7 ohm resistors in parallel, which will have the ohmage and give me 1.35 ohms, or I can put in two 2.2 ohm resistors in parallel, which will give me 1.1 ohms. Now there's another one of those power resistors up here on the board. I measured it with my doohickey, and it measured out at 1.5 ohms. It's probably drifted up a little bit. So I don't know how critical it is. I've probably got some 2.7 ohm 1 watt resistors. They're probably a little smaller. They'll fit in there a little better because it's a little crowded over there next to where that transformer goes. So I may, if I've got some 2.7 1 watts, I may put 2 of those in parallel. That'll give us a 1.35 ohm 2 watt resistor. Alright, so there the recapping job is done. I didn't have the correct, I didn't have a low enough replacement for this one. It's like 1.2 microfarad or something, not of a high enough voltage rating anyway, and I didn't have high enough voltage ratings for these two big ones. But they all tested fine. I pulled them out and checked them, and they were fine, and so were all the rest of the ones I pulled out. So that was probably a worthless endeavor, but I guess I was in there anyway. I went ahead and went with the 1.5 ohm 2 watt resistor, because this one down in here that I checked, you can kind of see it right there. It has a capacitor in parallel with it, and even if the ESR of the capacitor wasn't too great, that would have lowered the resistance value I was measuring on it, and it was measuring 1.5 even though it called for a 1.2. So I think it'll be fine. I hope. I guess we'll find out. Now I got to put the son of a bitch back together. I got you a front row seat for the fireworks here. I'm pretty skeptical. I think there's a reason that resistor burned, and with none of the capacitors testing terrible, I'm a little dubious, so it may just burn again. I don't know. This is making me really nervous. YOLO. I don't see any filament. I don't have the actual video signal hooked up. It's on this pass-through thing on this little piece of coax here, but the sync signal should be going out. Alright, unplugged my frame grabber, sorry about that. So yeah, I wasn't seeing any high voltage on the CRT there. The terminal board is beeping. I did hook up the video signal here. The video signal's on this thing here, but I've got it nabbed off of the board here. So, yeah, there's no filament voltage. I guess it's time to get the scope out and start probing. Alright, the white wire is supposed to be horizontal sync. Looks like we're getting some. Yep. Okay. The violet wire is supposed to be vertical sync. We're getting some. Okay. This one that I'm grab-derated on here is supposed to be the video signal, and it's probably not gonna show much. The only thing that's gonna be trying to display is a cursor, so I don't know how this will go. We've got something going on here. We've got a video signal coming out of there. Alright, so here's where the horizontal sync comes into the video analog board. Goes through a resistor, a low value capacitor, presumably ceramic, so we don't need to fuck with it. It gets pulled high through this resistor here. We got a diode. I don't know what the purpose of that diode is, but if we look at pin 2 of U201, we should still have a signal on it. So this is going to be great fun. I'm going to gingerly insert my tool into the hole and try not to short those pins. You rotten bastage. Okay, I'm gonna try it. If I die, edit the video and put it on YouTube for me. Of course, I don't have my time base set right. Hang on a minute. Alright, there we can see the sync pulses. Let's try this again. Pin 2 of U201. I was on the wrong one before anyway. I think that was U202. Okay, here goes electrocution time. Oh, that's a little funny looking, but maybe it's supposed to look like that. We're seeing the signal. I guess, yeah, that capacitor. I'm not sure what the dealio is here, but this capacitor right here is going to block the DC component of this TTL signal coming in here, and then this diode is going to clamp off the negative side of that. So that's probably why it was funny looking there. Now the output, pin 3 of U201, should have the same signal on it, I reckon. Okay, that looks like a horizontal sync pulse. Very good. Now pin 2 of U202 should have it. Oh, I forgot to switch over to the bench cam on that last one. Sorry about that. I'm a shit ass, but it's not like you can see it anyway, I guess, because it's all underneath everything here. U202. Get a good purchase on that bastage. Don't want to slip off and short myself and blow my stuff up. That would be unfortunate. Here goes nothing. Alright, we got a funny signal there too, but it is a signal. Let's look at the output, pin 3 of U202. It should have sync on it. Yes. Okay. Now, it goes through, comes out of pin 3 of U202 here, goes through this RC circuit. That's some kind of filter, I assume, and into this transistor. Q Pt.02. We want to look for a signal right there. I don't know what the pin arrangement of Q213 is, so I may have to look that up. Alright, I'm gonna take a break. I managed to blow the main fuse in the thing. I don't think I fried anything, and I'm not exactly sure how I did it. I traced the signal up to the collector of Q213 here. No, I'm full of shit. I traced the signal to this side of this transformer. That's the transformer that we desoldered. I'm getting a horizontal sync signal on that side of that transformer. Now, I can't see any signal on this side. And it was when I was fooling around trying to measure this side of the transformer that the fuse blew. I don't think I touched anything that I shouldn't have. And this, since both sides of this transformer are grounded eventually, it's not like it's isolated on this side. So I should be able to use the same ground that I've been probing with over here to probe here. So I don't know why I got nothing there. Perhaps the transformer is fucked up. I don't know. And I smelled something else funny. Burning things. So I'm not sure what that means. Bad news maybe, I don't know. Oh shit, here we go again. Next day, gentlemen. Had a little bit of dialogue with some of the fine people on the Society of 8-Bit Heathkit Computists mailing list, and this is Q204, I think. Q204 is this big bastard that I just pointed at. It's up here in the power supply section. This is the 63 volt power supply, or 53 volt power supply. Sorry, that runs the horizontal deflection down here, where we were screwing around yesterday. Right, so I was reading like 65 volts up there on that, and I thought it was just, that the voltage wasn't so critical, but apparently it is. They say that this Q204 is probably bad, possibly some of the other ones on this side of it. So this is, despite the funny Heathkit part number, this is actually a MJ2841. This transistor right here, right? And it's apparently very difficult to find these days, and very expensive on eBay. I think there were only like 2 or 3 listed, and they were all like $20 and $30 a piece. It's like, what the fuck? But I think a 2N 5038 would be a suitable replacement there. It's got about the same characteristics according to the data sheet, except it can handle higher voltages and more current. So it should be a direct replacement, I hope. That's what I'm going to try anyway. So I had to order some of those. I don't have any power transistors that big in stock. And considering that the H19 that doesn't have any flyback on it also doesn't have any flyback on it, I'm assuming that it has probably similar issues in the horizontal section, so I'm kind of afraid to take the transistors out of it to try in the Z89, because it probably has exactly the same problems, right? So yeah, I had to order that transistor, and so once we get so here's my theory, right? This is just a dumb theory. I may be absolutely full of shit because I don't know what I'm talking about half the time. So this 53 volt supply here, it was actually running like 65 volts. And so I think this transistor, this Q204, probably shorted first and caused all of this unregulated 65 volts to go onto the top end of the flyback transformer primary. And then that eventually caused this resistor to get hot and start to degrade, and maybe that is what melted it, and maybe when I replaced that resistor, maybe that's actually when Q214 ended up dying. I don't know. No, I wasn't. I was never getting any sync, so it was never working. So something caused Q214 to explode. And despite the funny Heath part number, that's actually a BU500 power transistor. It's hang on a second. That is this other big transistor over here. So I ordered some of them off of eBay as well. Hopefully they're not fake. I always, whenever I order shit off of eBay, I always make sure that I order from people that are located in the United States, because I think they're probably it's probably easier to get stuff that isn't fake that way, right? So anyway, what I did last night after I've finished recording was I tested all of this again and verified that I was getting horizontal sync up to this side of this T201, but I'm not getting anything on this side of that transformer. So this is the resistor that burned right here that I replaced with that 1.5 ohm 2-watt resistor, and I replaced this capacitor, and I replaced this capacitor. I did not replace this resistor here, but it tested at 1.5 ohms, which is why I put the 1.5 ohm resistor in here. So this one had drifted a little high too. But I tested all of these components, and they all test good. I compared the impedances of both the primary and secondary windings of T201 to those in the working Z19, and the impedances were exactly the same. I checked the impedance of the primary winding and the filament winding of the flyback transformer against the one in the working Z19, and they were all the same. So the only thing that I've got here left is Q214, which I haven't taken out of circuit and tested yet. The guys on the Society of 8-Bit Heathkit Computing Enthusiasts also said that it was very important that this be a 1.2 ohm resistor, and that 1.5 ohms wasn't sufficient. So, but I went ahead and ordered some carbon film resistors, 2-watt, 1.2 ohm carbon film resistors as well. Basically, I'm waiting on parts for this thing now. I'm going to pull Q214 and Q204 and test them on a diode tester, and if I probably ought to test all the rest of these as well. Hopefully these are just common BJTs that I've got in my loot box, or at least appropriate substitutes for them. This machine is being a really rough repair. It just seems like it's got all sorts of stuff wrong with it, but that just makes it more interesting, I think. So cool. At least it was fairly cheap in comparison to what Z89s normally go for. There's a thing down there in the thing, wherever it is. Join the Discord channel if you want to. I mean, we're kind of boring these days until the spicy stuff gets gone, and then we're just offensive. But come over and we can talk about stuff. Be a good time. The whole reason I do this is because I don't have any buddies in real life that are into this sort of shit, you know. So it's nice to make some internet friends to talk about this stuff. What is this? What is my soldering iron cable hanging down here in front of the camera for? What kind of 2-bit operation is this? Jesus Christ. So professional around here. Anyway, see you next time.